bright moon, which seems so big and magical in the night sky, can affect our thoughts and emotions. The moon can also affect behavior of animals. Many, such as certain fish and deer, often become more active when the moon is full. But perhaps the strongest effect of the moon is on Earth itself. The moon and Earth have been dancing together for billions of years. Earth, nearly 4 times the moon's diameter, clearly leads the dance. But the moon in turn has important influences on Earth. Let's look closer at the moon and its partner Earth as they sweep through time and space together. There is no other place in space we know as well as the moon. It's close enough we can study a number of features with the unaided eye, and lots of details with a modest telescope. And more than that, the moon is the only place in space where humans have set foot. In a history book journey on July 20th, 1969, Neil Armstrong stepped from the Apollo 11 lunar lander onto the moon's surface.
That's one small step for man, one giant leap for mankind.
This trip, plus the others that followed, brought back samples of moon rocks and dust, and some out-of-this-world experiences.
Okay, turn sharp. He's a big rooster tail out of all 4 wheels. And as he turns, he skids, the back end breaks loose just like on snow. Come on back, John.
The moon and Earth appear to have both formed at the same time, about 4.5 billion years ago, from more or less the same type of material. We are not exactly sure how the moon got started. Many scientists think the moon developed separately from the same cluster of space particles that formed Earth. Others suggest that the moon was created when Earth was struck by an object the size of a small planet. This object knocked chunks out of Earth and kept going. The chunks eventually regrouped in Earth orbit to form the moon. At first, the moon and Earth were so hot they were molten or melted. Gradually, their surfaces cooled to make crusts. While the crusts formed, meteorites bombarded the moon, and probably Earth as well. Billions of years ago, space was much more cluttered with chunks of rock and metal that collided with things in their path. The hardened crust of the moon preserved some of those countless early impact craters. Soon after the moon's crust developed, heat trapped below forced up volcanoes. These volcanoes spread lava across large areas of the moon, covering up some of the impact craters and forming the smooth, dark areas we today call maria. Maria is plural for mare, which means sea. People once thought these might be oceans. Today, we know they are lava fields. Since the volcanoes ended their activity 3 billion years ago, the moon's surface has hardly changed. Earth's surface, on the other hand, has never stopped changing. Earth has not cooled as much because it's bigger, and its crust remains thin and weak. In fact, the crust is cracked into about 20 pieces called tectonic plates. These tectonic plates creep over the molten rock below. By creating mountains, volcanoes, and other surface features, tectonic plate movement slowly but constantly changes the look of our planet. Erosion also changes Earth's surface. The Moon lacks erosion-causing surface water and wind. And though Earth and the Moon had similar starts, they have taken quite different paths, mainly because of their difference in size. Moons are not unusual in the solar system. In fact, well over 100 moons orbit other planets. Many of the moons around the solar system are only a few hundred miles or kilometers across, but a couple are larger than Mercury. Earth's moon is mid-sized among those of the solar system. However, in proportion to Earth, our moon is quite big. Only Pluto's moon is proportionately larger. One of the moon's most noticeable effects on Earth are ocean tides. Tides are the regular rise and fall of the ocean's level. In the open ocean, high tide raises the water level about 3 feet, or 1 meter, over the low tide. Along coasts, tide levels vary because of coastline shape. In particular, shallow bays concentrate water into a small area and increase tide height. The world's highest tides, reaching nearly 45 feet or 15 meters, occur in the Bay of Fundy on Canada's east coast. The moon creates tides through its pull of gravity. This pull is not enough to affect Earth's crust much, but it is enough to cause a distinct bulge to the ocean. To appreciate the strength of gravity, feel how heavy a single bucketful of water is. Then, consider that the moon at any given moment is lifting a sizable portion of the world's water. The high tide ocean bulge always stays with the moon as Earth rapidly rotates below once a day, and as the moon travels around Earth about once a month. From high above the North Pole, we can compare the progress of the high tide to our rotating Earth and see the big difference in speeds. As we'll learn later, this difference in speeds has important consequences. We also can see a second ocean bulge on the backside of Earth. This is water less affected by Moon's gravity because it is farther away from the Moon. When this backside bulge passes by, it creates a second high tide for the day. So every day, ocean coasts have 2 high tides and 2 low tides. The time at which high tides occur change slightly every day. Remember, as Earth spins, the Moon moves in its orbit around Earth. So by the time this point on Earth circles around again 24 hours later, the Moon has moved ahead to over here. High tide at this point will have to wait until Earth catches up with the Moon, roughly 50 minutes later. Also, long ago, scientists noticed high tide bulges don't travel exactly in line with the Moon. They travel slightly ahead of it. Why? As Earth spins around quickly below the ocean bulge, friction between Earth and the water push the water ahead of the Moon just a little. Over long periods, This friction and the timing difference between the Earth's rapid rotation and the Moon's slow orbit affects both dance partners. In particular, astronomers calculate that every century, because of the Moon's pull, Earth's rotation takes about 1/500th of a second longer. A billion years ago, a day on Earth was only 19 hours instead of 24. In another billion years, a day will have stretched to 30 hours. Earth's gravity has affected the Moon perhaps even more strongly by pulling the Moon into a synchronized orbit. That is, the Moon rotates on its axis at the same rate it orbits Earth. As a result, we always see the same side of the Moon. Astronomers think that maybe this side of the Moon is slightly heavier than the far side, and as a result is pulled harder by gravity. Though we always see the same side of the Moon doesn't always look the same. Over a period of about 29 days, the Moon goes through a series of phases. As shown here, the Moon is lit by the Sun, and we see the reflected light. As the Moon circles Earth, we see that lighted Moon face from a different angle. When the Moon is here, we see a big, bright full moon. As the Moon moves over here, the fullness gradually decreases. The line separating the light and dark sections is called the terminator. After about 14 days of travel, the Moon has circled halfway around its orbit path, so it now lies between Earth and the Sun. We no longer can see the Moon at night. We call this moon phase the new moon. After the new moon, the Moon swings past the Sun, and its face gradually waxes or increases in size until it's big, bright, and full about 2 weeks later. Once in a while, when Earth gets between the Sun and Moon, things line up so that Earth casts a shadow on the Moon. This creates a lunar eclipse. The lunar eclipse can take a couple of hours as Earth's huge shadow passes by. During this time, a bit of light refracting through Earth's atmosphere may keep the Moon visible, though red in color. When the Moon passes in front of the Sun, usually its shadow misses Earth. But sometimes the shadow does land on us. This event is called a solar eclipse. The Moon may only partially block the Sun, which we call a partial eclipse. When the Moon completely blocks the Sun, we enjoy a rare full solar eclipse. The full eclipse lasts only minutes. By chance, we live at a time when the Moon and Sun appear the same size in the sky. However, the Moon is slowly moving away from Earth, about 1.5 inches or 3 centimeters per year. In 10 million years, the Moon will have moved so far away, it no longer will affect tides. Eventually, Earth's rotation and the Moon's orbit will synchronize because of the slow drag of tides and the Moon's pull of gravity. Then both Moon and Earth will dance, locked face to face, until they cease to exist.